do PowerPoints if that's okay with people, but I'll just say a few words really about what UKCRIC is. So UKCRIC stands for the UK Collaboratorium, which is a made-up word. It's meant to be a cross between collaboration and laboratory. It's the Collaboratorium for Research on Infrastructure and Cities. So it's probably been going now for about 5 years, and it was initially kicked off by a major investment from Bayes under the coalition government, if anybody remembers that thing, which seems a long time ago now. And it was a period of time when they wanted to invest in capital projects to try to sort of help kickstart the UK economy. And they also wanted to invest in research infrastructure. So there was a huge consultation which went on with all sorts of people around the academic community. And at the time, it was recognised, they just made major investments in things like materials, which was the Royce Institute. There was the Dorothy Hodgkin Institute. There was Turing and so on. And we realised that with £600 billion proposed to be spent on national infrastructure over the coming decades, the amount of money that was spent on research and our capability for doing research related to infrastructure and cities was pitifully small. So the case was made and eventually accepted that we should establish this essentially a research centre for research on infrastructure and cities. And so UKCRIN was born. And in contrast to some of the other institutes, we also felt that it shouldn't have a single physical location. So deliberately, it was distributed around the UK. And I think there were initially about 13 partner universities. I say around the UK, to be perfectly honest, for various political reasons, it was actually initially in England, and that was to do with where the funding came from, because initially the devolved nations weren't involved in that. We've since brought on board Edinburgh and Heriot-Watt, and our intention is to try to make sure that we have a partner in due course in Wales and one in Northern Ireland. And if we do that, then every region in the UK will be represented in UKCRIC. One of the problems with UKCRIC, I suppose, is that it was very much an investment in capital. So it was what we might call batteries not included. So we have got these wonderful facilities. So I don't know where you're all from, but some of you are from Southampton, so you will know that the National Infrastructure Laboratory, that is actually a UKCRIC facility. And we have got other facilities that are complementary facilities in most of the other UKCRIC partner universities. They very often have a particular specialism. So just to pick a few fairly much at random, Birmingham is buried infrastructure. Bristol is sort of especially dynamic soil structure interaction. Cambridge is sensing. Cranfield and Sheffield both do water. And then we have got Manchester and Imperial who do materials. So the idea is that we have got complementary facilities, but equally recognising that there are going to be some things where you need them at a local level, some things at a regional level, and some things genuinely at national level. So we're now in the position with UKCRIC that we have got these wonderful facilities. We've also got the community, of which you are all very much part. I've been muted this whole time. Jenny, have I been muted?
No, you're not muted.
Okay, all right. My mute just came up, so somebody possibly tried to shut me up. So you don't need to do that. So I'm not quite sure where I lost things.
We've heard you all the way along. I was
okay.
Just see whether. But
okay, good. Now I suddenly noticed it was mute. It was muted, which gave me a bit of a. So you're very much part of the community. We have recently taken the initiative to try to actually start to get a collaboration across doctoral training centres across the whole of UKCRIC. Jenny is leading that, and so what we're starting to do is to have opportunities for people to come to seminars, and hopefully in due course, when we've well and truly worked out what we're going to be doing with COVID or post-COVID, whichever of those it happens to be, we will hopefully be able to have some physical events as well. The last thing I'd like to say, I think, is that fairly early doors in UKCRIC, we had these regular, what we called all hands meetings. And those were in the days when we were still able to sort of travel and meet together. And they were quite productive. And we had a series of meetings where we developed what we now call the UKCRIC missions. So the UKCRIC missions are infrastructure and urban systems for one planet living, which is what we might call a sustainability mission. There is one on ownership, governance and business models for infrastructure and urban systems, and that is what we might call affordability, because our infrastructure has to be affordable. There is what we call transformational infrastructure and urban systems for a changing world, and that is really about adaptable and resilient infrastructure. The world changes, for example, climate change is an example of that, but also changes in the way we use infrastructure. So again, to take one example that I was involved with, when we moved the way we dealt with waste from landfilling to recycling, we realized that it's not just about saying, yesterday we did landfill, tomorrow we do recycling. You need to have infrastructure and systems in place that do that. You need to have the facilities which deal with the waste. People need to do what they need to do in the home. So that might be about sorting their waste into sensible buckets so that you don't end up with cross-contamination. You need contracts for waste recovery and waste collection. You need if you're going to go to recycling, you need to have markets for the recovered materials. And we still haven't really cracked that. And it just shows that transitioning an infrastructure is really very difficult. Another key challenge is going to be electric vehicles. It's not going to be possible, and nor should we even think of it, to replace all of the cars that people currently have with electric vehicles. We've got to be viewing mobility very differently in the future, maybe having vehicles that we only use when we want to go from one place to another. We're going to have to up our game in terms of public transport, trains and buses, partly because of the huge energy benefits of transporting people by train rather than by road. So just as for example, in terms of kilowatt hours per seat kilometre or watt hours per seat kilometre, a Pendolino train travelling at 140 kilometres per hour uses half the energy as a car travelling at half the speed. So basically the train, because of the low friction that we have between a steel wheel and steel rail, is probably at least 4 times as efficient, possibly more. Another interesting fact was certainly before the recent energy price rises, the cost of the electricity to take a pretty much an 11-coach Pendolino from London to Manchester was about £130. So the cost of electricity the cost of energy is relatively low for trains. So transitioning our infrastructure is going to be difficult. And then the fourth one is what we call infrastructure and urban systems as drivers of equity, inclusion and social justice. This is recognizing that our infrastructure and our cities have got a huge influence in helping people to live more sustainable, more healthy, more fulfilled lives. And if you like, that particular mission is about levelling up before the phrase was invented by the current government. Now, people very often say to me, but I'm interested in the properties of concrete. How does that fit into the UKCRIC missions? Well, the reality is that if we can make our concrete more sustainable, if we can actually use less of it, all of those things will play into the UKCRIC missions. So what we're doing at the moment is that we're in the process of fleshing out research agenda for those 4 missions. So that will be a work in progress, which will come up on the UKCRIC website. So that's pretty much an introduction to UKCRIC. So I'm sorry I didn't have the visuals, but we can do a death by PowerPoint. We can find some slides, which are on my other computer, unfortunately. We can find some slides and we can make those available. But that's what UKCRIC is. Hopefully everybody will feel that they're part of the UKCRIC community. We've got web pages that you can look at and you can get involved as we develop policies and procedures and agenda for research, which hopefully will then feed in to obtaining funding as we move forward. So that's really it from me on UKCRIC. I don't know, Jenny, I'd be happy to take any questions if we have time for questions, but if we need to move on, we can move on. So I'll hand back to Jenny.
Thank you very much, William. We do have a few minutes for questions if anybody had any that they wanted to raise right now.
And if you want to put them in the chat, we can look at them in the chat. That's entirely up to you. I know these big meetings can be difficult. Okay, but if people think of them as we go through, Jenny, they can put them on the chat and we can get them answered. But that's sort of UKCRIC in a nutshell. Okay.
Perfect. Thank you very much for that.
Thanks.
Very succinct and to the point. Perfect. So I would like to invite Will Jones to present to us next.
Yeah, hi there. I'll just share my screen. Can you see my screen yet?
Not yet.
Okay, it should be coming through. It should be coming through, I think.
Yes, there it is. Thank you.
Okay. Sorry, it's just taking a little while to load at the moment. It's nearly there. Yeah, it seems very slow at the moment. I haven't had this. Sometimes when I first turn on my laptop, it's quite slow. At the moment, though, I seem to be having some issues. Okay. Right, so can you see that?
Yes, we can.
Yeah, you're on.
Okay, right, it's finally working. Good. Okay, so my name is Will Crawford-Jones. My PhD project is titled Fundamental Insights into Sediment Transport. Okay, so just to briefly go over the content of the presentation. First of all, I'm going to speak about the motivation behind this project. Then I'm going to go over the PhD objectives with particular emphasis on the first objective. I have 3 objectives overall, but I don't think I have time today to speak about the second and third ones, but I'm mainly just going to be concentrating on the first. And then I'll be speaking about some initial results. So, as I said, my project is about sediment transport. So what are the applications of sediment transport? In general, we want to be able to predict the morphodynamics of rivers and coasts with time. More specifically, in cases where we have river engineering, so perhaps river straightening, river widening, construction of building or structures that are partly submerged in rivers. When we have that, we get quite a change in the level of sediment transport. But also, sediment transport itself affects the severity of river flooding. So if you model a flooded river or flooding river, and then you don't consider sediment transport, then that will massively underestimate the severity of the flooding. If you do account for sediment transport, then you get, of course, that's a more realistic scenario, and you get generally you'll get a more severe flood. So those are just some of the applications of sediment transport. But the models that we currently have, in general, aren't particularly accurate. So we have this paper from 2007 that tested a selection of the commonly used sediment transport models. And if you looked at the least accurate models, they were only accurate in 13% of the field data sets. In some of the more accurate models, there was a slight improvement, but it still wasn't a huge amount better than 13%. But the thing is, the catch here is I'm defining accurate as this, so the computed transport rate divided by the measured transport rate, and somewhere between 0.5 and 2, which in itself isn't particularly indicative of an accurate model. So that briefly goes over some of the motivation and the fact that we need to improve on the models that we currently have. So now over to what I'm going to be doing and what I have been doing. So my objectives are, first of all, I'm studying the Shields curve, which I'll talk about in a second. More specifically, trying to understand the hydrodynamic physical mechanisms behind the shape of the curve. I'll mention that in 1 second. I have two other objectives, which are about the impulse criterion. I won't discuss them today. The impulse criterion is related to the idea that not only do you need a given drag force to result in sediment dislodgement, but you need that drag force to last a given period of time. I've included this video here. Hopefully I don't have too many technical issues. So the reason I've included this was just to show what I'm going to be doing. I'm studying the Shields curve through a CFD analysis, which is going to be a massively idealized case. But of course, in reality, we get a much more complex scenario. So in this case, you can see there's all sorts of degrees of freedom and factors we need to consider in a realistic case. We have differing sediment sizes, differing sediment shapes, perhaps different friction coefficients, different particle protrusions, different shape channels, and all sorts of other things that we need to consider. But in my case, it's going to be a CFD study, which means it has to be hugely idealized. But what I'm going to be discussing generally today is this first objective, which is about the shape of the Shields curve. And just have to wait a second while my laptop struggles to open the slides. Okay, so sorry, 1 second. So I said I'd discuss the Shields curve because that's related to my first objective. And here is the Shields curve. Basically what it shows initiation of motion of different sediment particles or of different size sediment particles. So along the x-axis here, we have something that relates to the sediment size. Along the y-axis here, we have what is known as the critical Shields parameter, or the Shields parameter rather, which relates to the bed shear stress, which is basically related to the hydrodynamic forces on the sediment particles. So the Shields parameter relates to the bed shear stress, which relates to the drag forces. This means the average drag forces, in fact, on those sediment particles. And that just briefly describes what the Shields curve is. So there are numerous ideas as to why it has this kind of shape, but there's no empirical proof. So as I said, I'm going to be doing a CFD study to recreate my own Shields curve in this highly idealized environment. I'm going to vary the sediment size, the relative roughness, which is the ratio of the sediment diameter to channel depth, as well as other factors such as the particle protrusion, and record the pressure on this particle, which is an unsecured particle, so I can watch this dislodge and record the forces on it as it dislodges. The rest of these particles in this image are just static. They can't move. They just represent the sediment bed, basically. And I can create my own Shields curve, determine the Shields parameter, and see at which point this starts to move. And then I can compare this against the real Shields curve that's derived in the field. But the other thing I want to do is try and work out why it has this shape, and that's related to these 3 points A, B, and C here. So the first point, as I said, this Shields parameter here, this relates to the average drag forces on the bulk of the channel bed. But I want to compare that to this little variable here, which is related to the average drag force just on this particle, which is the particle that's going to dislodge. So that's the first thing I'm going to consider in the CFD study. The second thing is this, which is how does this average drag force relate to the more instantaneous drag force that actually results in sediment dislodgement? That's another relationship that I'm going to study. And then thirdly, we have that same drag force that results in dislodgement and compare it against that same drag force, but with the lift forces removed. So here we have these three different relationships, or three different ratios that I'm going to consider. And it's my hypothesis, as well as some other people have hypothesized it, that as those three ratios vary across the sediment size, that's what gives it this trend. But I want to prove that that's the case with my CFD study. And what's going to happen is, you can see this is taken from a paper from 2003. This is the standard Shields curve, and then as you start defining the Shields parameter in these different ways, they were able to show mathematically, rather than empirically like I will, that you end up with a flat horizontal line. But these different lines are just different ways of defining the Shields curve, and you can see the effect that each of these things, these three relationships I've mentioned, three ratios, have on the shape of the curve by seeing how it changes as you vary the definition. So finally, just to speak very briefly about some initial results. Of course, I need a contact model because I have this sediment particle that's mobile, it's unsecured, and it has to be in contact with these. So I've derived a contact model, which I'm starting to encode into the CFD software, which is StarCCM that I've been using. But at the moment, I haven't got the results such that I can produce my own Shields curve, just because it all hinges on me encoding this contact model. So far, however, I've run some simple test cases. You can see the sediment particle dislodging with the built-in contact model in StarCCM. But at the moment, for me, that's not accurate enough. I need something that's slightly better. Hence why I've got my own contact model. And that's everything I'm going to say today. So I've briefly gone over the motivation behind this project, outlined the objectives, and briefly discussed some initial results. But there's more work required until I can get my own accurate data.
Thank you very much, Will. Did anyone have any questions for Will about that presentation or his research work at this point in time? No, well, if not, pop it in the chat if you have any thoughts as we go along, and I will hand over next to Freya. Freya, are you there?
Hello.
Hello, welcome.
Hiya.
I'll let you introduce yourself and get your slides all sorted.
Yeah, sure. I just get set up 1 second.
Absolutely fine.
Okay. Can you all see that okay?
I can see the working screen.
Yeah. There we go. Okay, so I'm Freya Bradford and I am in my final year of my PhD now, just a couple of months left. And my work's been looking at microplastics in agricultural soils with specific focus on methods of detection, sources of plastics, and then the fate of those plastics. So I just wanted to start off by defining microplastics. So they're any plastic piece of plastic that's under 5 millimeters in size. And we've done a fair bit of research now in terms of plastics in the ocean and understanding their sources, their movements, and their impacts in the ocean. And it's been quite well publicized. So we've had things like Blue Planet, which obviously makes it quite a hot topic at the moment. But there is a lot more to learn, particularly about the terrestrial environment. With regards to soils, we don't know very much about what's happening in terms of plastics. And given that 80% of ocean plastics come from the land, it's likely that the proximity to source will mean that there's a lot of plastic in these soils. So I just wanted to cover why soils are of such importance. So the first reason is their importance for biodiversity. So 1 teaspoon of soil can contain up to 50 billion microbes, and it provides a habitat for lots of different types of organisms of all different levels. It's also important for food production. So within the UK, 70% of land is used for agricultural purposes, and within the world, it's 39% of the land is used for agriculture. So we need it to be able to provide food security around the world. And then also we have the importance of it as a raw material. So it's used for structural materials such as bricks and concrete. However, soil's under a lot of threat at the moment. There are lots of different things that are causing problems. So things like soil sealing, climate change, compaction, erosion, and particularly what we're going to focus on here is contamination, especially with regards to microplastics. So there's many different sources of plastic within soils. It can come from lots of different areas or has been suggested to. So things like airborne transport of plastics and plasticulture, which is the use of plastic in agriculture to improve soil quality, things like moisture content and temperatures, and that increases yields in crops. And then things like littering will also potentially be a source of plastic. So things like fly tipping or roadside litter will potentially be getting into the soils. And then other things like agricultural plastics, so general silage wrap, bale twines, things like that that they use on farms every day might increase plastics in soils. Irrigation is another one, so there might be plastic in the water that they use to irrigate the farmlands. And then also soil amendments, so things like composts might include plastic. But the one that I want to focus on here is sewage sludge. So sewage sludge is the solid byproduct of the wastewater treatment process. It basically is all of the solid fraction that comes out of cleaning up wastewater, and it's been shown to contain really high levels of microplastics. So farmers use sewage sludge as a resource, as a fertilizer to add to agricultural land. They spread it on the land to increase organic content and to help improve crop yields again. But if there are so many plastics, so some studies have reported that there are millions of microplastics in 1 kilogram of sludge, and they spread many kilograms of sludge across the field, there must be plastic going into that system, which is what I have tried to look at here. So I've got a few initial results to share with you. So to start off with, I looked at different fields which had sludge spread on them and then ones which had never had sludge spread on them to compare whether the plastic composition and quantities were similar between the different fields. So initially I've found that there is a slight increase in the fields that have sludge spread on them. However, there is a lot of variation within the results, so this actually isn't significant. The non-sludge fields essentially don't have a different amount of plastic to the sludge fields, which is maybe not what we would have expected. So to further clarify this, I went on to look at the fate of the plastics. So with regards to before and after sludge application, what's happening to those microplastics? Where are they going? So I sampled before sludge application, and then the sludge application happened and I sampled 1 week after, then 1 month, 3 months and 1 year after that application. I then extracted the microplastics and characterized the different polymer types for each of these events. And again, I've got a few initial results to share with you. So to start off with, I looked at the quantities of microplastics in soils. So this is how many microplastics in terms of numbers were there per kilogram. And I related that to the rainfall within those different months that I sampled. So at the moment, there's not a clear explanation for what's going on, because initially we find that before sludge application, there's actually more microplastics. So if you look at the dark green line here, the microplastics quantities go down after sludge application, so the 1 week after event. But then rainfall seems to be going up during that time, and after the sludge application, it seems to follow the same trend. So as the microplastics go down, the rainfall seems to go down and increase again at the 3 month mark and down again at the 1 year mark. It's also interesting to consider that in terms of the different farms that I sampled. So I sampled 5 different farms at this point, and each one had a different polymer composition. So here you can see that farm 1 had a much more diverse polymer composition, which suggests that potentially there are more sources inputting into that farm in particular than we may have first thought of. So going back to those initial sources that I mentioned, things like the airborne plastics, this might be something to do with localized rainfall, as studies have shown that with rainfall comes increased deposition of airborne plastics. So that might be potentially an explanation for that one. There might also be different things in terms of the way that they use agricultural plastics on those lands. So I controlled for things like there was no use of plasticulture on the land, and they all cultivated the fields to the same depth across the different farms. But it might be that individual things like the type of crop that they used, which might require different fertilizers that come in different kinds of plastic containers, may have been used within the different farms. So my next step is to try and work out why there are these differences between the different farms and between the different time points, and to try and explain some of the variation that I am seeing here. So that's all I've got for now. Thank you for listening.
Thank you very much, Freya. That was really very interesting. And it's good to see kind of the different sorts of research that's kind of occurring kind of within this CDT. It's all very wide ranging, but yeah, kind of from the same sort of standpoint. So thank you very much. Did anyone have any specific questions to ask Freya at this time? We're very quiet. With a wake out there. No? If not, then thank you very much, Freya, and
Thanks,
we will
Jenny.
invite Greg to come and join us.
Hello.
Hello, Greg. Welcome to the party.
Oh, thanks. I'll just share. Can you see that?
I can see the working screen, yep.
Awesome. And can you see that now?
Presentation there and ready. Thank you very much.
Okay. Great. Hello, everybody. My name's Greg, and I'm a second-year PhD student at Southampton. And this is the title of my PhD. It's Investigating Intergenerational Links Within Household Energy Consumption. And today's just going to be incredibly brief, not much detail at all, I'm afraid. And I'm going to look at two pilot studies that I've been working on. The first one is called Energy in the Home, and the other one is kidsforclimate.co.uk. So what is the big issue that I'm looking at? And it is, of course, essentially housing and the CO2 and emissions and energy that they consume, and how actually it's far bigger than people think. So here is a breakdown of an actual house, and you'll see that space heating at the top right is massive. Over 60% of a house's energy comes from space heating. Is used by space heating. And there's many reasons for this. Potentially bad homes, inefficient heating, the grid is getting better, but it's still bad. British weather requires obviously more heating, but the ones I'm looking at is going to be the occupants themselves, their knowledge and how that drives their behaviour in the home, when they use the heating, how they use the heating, how they use their windows, whether they're over-ventilating. All these sort of things can lead to overconsumption of energy for heating. So this is my actual research, and here's a diagram of what I'm doing. So I'm going to be targeting children, and I'm going to be hopefully doing some sort of activities that improve their knowledge, make them question behaviour in the home, sort of increase their energy literacy is the buzzword. And then I'm going to see if they can take that knowledge home and whether they disseminate it towards their parents, to their grandparents, to their other peers that they live with, and whether that actually changes parents' attitudes, parents' behaviour in the home, and in the end, that will reduce heating, reduce energy consumption, and reduce their CO2 emissions. So that moves me on to my first pilot study, which was the energy in the home. And the aim of that is to look at what I should be teaching, how I should be teaching, etc. When sort of all these different topics that occur, what they already know, what they should know, and how I'm going to gather feedback, how I'm going to actually measure an improvement, all of these sort of things. Oh, and the key one, of course, is how to create the opportunity for that transference of knowledge. So for the last year, I have been in primary schools, specifically Woodcote Primary School, which is by Portsmouth. It's quite a small class, 13 each year and around 200 students in total. And what I've been doing with them is producing lessons. So these are 4 lessons that were key to an energy day. So every class did all 4 of these lessons in a single day. And the first one, looking after a planet, is just an introduction. The second one is looking at carbon footprints, so food and anything, or just everything around us and the energy that's used to create those. The third one is essentially just about energy, renewables, fossil fuels, power, what uses it, how we use it, and where it comes from. And then the fourth one, which was the most important, was sort of a DT lesson. And in that, I introduced them to the energy detective game, which is essentially a game of snakes and ladders that they will take home, play with their parents, and as they go up through the snakes and ladders, they're asked to do different tasks around the house. So they spent the lesson essentially drawing their home. It was more collage-y than this in the end, but then the idea was to get them looking at their home, what's in it, what uses energy, etc. And then as they landed, they would have to choose a different card from these cards on the left. So for example, how many windows are open? If they chose that one, it would associate with a room on the level that they're in their home. So it's got living room, kitchen, dining room, bathroom, bedroom, and other bedrooms as you go up the snakes and ladders. And then they would write down their answer. So they were looking at different parts of their house and different ways that energy is used, consumed, etc. And the idea of this was that it would get them looking, get them asking questions, get them potentially playing with their parents as well, not really annoying their parents, but just asking the questions and making everyone think about decisions before they do them in the home. There was also a parental survey that went out after this. So they played this for about a week, hopefully each night, and most of them did. So they were asked about the content, then the parents were asked about the engagement with the game, did they enjoy it, etc. Then asked about the behaviour. So have the children asked if things can be done differently in the home? Have they asked if they can eat different foods, for example? Because I was mentioning how dairy and meats are worse in terms of energy consumption to be grown and made than vegetables, for example. Then finally, have the parents learned anything new, etc.? Do they think they'll continue with these changes, or would they like to know more about the planet? And then here are just some results from the children. So there was one task where they had to look at their lunch and calculate the CO2 in their food. There's one of the basic games that I saw from Stanley, good lad. And then they were looking at what they do in the day. So they did a comic of their day and what uses energy. And then there was with the teachers, they were doing some mind maps, etc., about what they knew already. This was at the start of the lesson. And you see some quite humorous things there. Change on Earth is a good one though, but the smell of your feet, probably not. And then, so this is results from that feedback from the parents. So there's quite a lot there, but I'm just going to circle some key ones. Has your child talked about what they learnt? And 89% said yes, that's fantastic. They're actually talking to their parents. So there are actual occasions where there could be transmittance of knowledge. Have you spoken about how they think they can help the planet? They all said yes, that's absolutely fantastic. And then further down, do you think you will continue with this change? I didn't get them to say what change, but any changes they've mentioned. So again, 90%, that's fantastic. And then has your child asked you for things in the home can be done differently? Again, 90%. So that's a very similar question, actually. But it's all very positive feedback from the parents. Here's feedback from the teachers and from the children. So this was all verbal. After they did it for a week, I got the teachers to ask these questions, and they all came back extremely positive. The kids loved playing the game. They learnt lots. They enjoyed it all. So there was lots of debate whether they would enjoy science. It's quite heavy science, talking about climate change and greenhouse gases, etc. But they all loved it. The curriculum sort of aims this towards secondary age, whereas I was pushing it towards primary, but it actually turned out very good. One class teaching assistant said that she's learned huge amounts and she'll be attempting to change her daily decisions. So it's great that it's actually targeting more than what I was expecting, so that adults are actually talking about it too. And then one boy, when learning about threat to wildlife, he became quite upset and had to be comforted by the teacher, but he's actually since adopted a polar bear. So although it was quite a shock initially, and there are always worries about anxiety that's like becoming a more common trend in children. So there's some grey areas that need to be looked at on how much I tell them and sort of how much I talk about how bad it's going to be in the future. But then another boy, after learning about their lunches and calculating it, he did it every day for the next week and getting a better and better lunch in terms of lower carbon every day, which is great. And I plan to go back this year to the school and talk to them all again and see if things are actually still going, because I think that would be fantastic, and see where I can go next. And then one class in particular took it much further and carried the eco environment into all of their other subjects that term. So in DT, they were doing foods, they made cookies about the world. In English, I presume, they were doing poems, and so they started writing about the planet. So this girl wrote one about global warming, which is fantastic. And then apparently in 2 of the classes, actually, they haven't been allowed to turn the lights back on yet, which is fantastic. And this is exactly what I wanted to see. And it's kids actually taking like control almost, and just pushing the behavior onto the parents, onto the adults, and saying, actually, what you've been doing is wrong. Let's do it properly. It's fantastic. And that has evolved into my year 2 study. So I now have a large participant group from a company called Igloo Energy, and I plan to use them. I have all these lessons that I've put together. I've got lots within the lessons. There's lots and lots of activities. I have a take-home activity that like almost promotes the communication in the house. But with this new Igloo participant, it's not within one school. There's 25,000 people across the UK that I have data for, that I'd like to go out and reach. So I need to think of a new way of sort of combining all of this for a new participant group, because of course, I can't send home a lessons activity, that they've done in class, because there's no class either. So I need to come up with a new thing. And that's led me to kidsforclimate.co.uk, which is this website that I've been developing over the past few months. It's essentially all of those lessons combined into different rooms around the home. So instead of learning basics of climate change and then taking it further, when they look at the boiler room, for example, because that's sort of obviously no one has a boiler room exactly, but it's a key part of the home. So they'll learn about climate change in there. And when they go in the garden, they'll learn about animals and wildlife. When they're in the kitchen, they're learning about food and plastics. In the drive, they're learning about fuels and cars, etc. So when they click on a room, I created 8 different about 2 or 3 minute videos. They're all cartoon with me speaking over, sort of stop motion drawing cartoon. That's all I could really do. I don't have access or funds to animators on board or anything. And then once they've watched the video, the website asks them to play a game, and then they go around that room or that part of the house or look at that sort of topic. So for example, in the lounges are kind of boring, but there's lots of tech in them. So there's looking at standby, how much energy we use, how many windows are open just in your house generally. I've got to slip in these big house ones sometimes and see how many they can close. So some of these questions they answer every day. Some of them are only accessible every week or twice a day. So for example, how many windows could you open? I'll ask them. Hopefully the idea is that they play in the morning and in the evening. They'll probably only watch the video once initially, but then they carry on with this. And as they keep inputting things, they get more scores, they get more points. And I have a leaderboard that's currently undergoing a little bit of sort of improvement. So there's badges and rewards now as they get more points, which encourages, continual play. And as they go through, they get more points, like I said. And then over the heating period, over the next 3 months, I should be able to get a very good representation of how they use their home and sort of the parts in which they've improved their knowledge. So here are my participants. I'm going to split them in half. I'm hoping for 1,500 people to actually take part out of the 20,000. Half of them won't do anything except for fill out some questionnaires about how they use their home and how they talk to their kids. The other half will do that, and they'll also do my Kids for Climate website. Hopefully they'll do that for a prolonged time, and then I should see a difference between the CO2s which I have access to because I have access to their, not particularly CO2, but I have access to their meter readings for electricity and gas and water through the energy company, which is fantastic. So I should be able to see a comparison with whether or not the children have actually affected energy use in the home. So this is going to be released imminently. It was supposed to be released a few weeks ago, but in the end, as always, it's been put back a month. If it proves successful, the actual aim is to develop an app that could become national, that could be sold, that could be used in all over schools all over the country, along with lessons, etc. And the end goal is to actually improve the national curriculum and really improve what kids are learning earlier. I'm currently in talks with 4 different schools as well. So Woodcott is where I did the initial test. Coxley's is a special educational needs school, so I wanted to see how I could alter or change things to a different audience. I'm also in talks about curriculum with Woolhampton Prep School in Lymington. I actually am, sorry, no, I do work with them previously as well, so this is sort of an input, an extra. I'm sort of using them as an outside experiment really, to see whether I can do things because that's a boarding school, so it's very different. They obviously don't go home, so it's very much more about how they use the school, which is a very different building and a very different place to homes, but still essentially the same issues. And then I'm also teaching in the University Summer School. If anyone would like to come to that, I think anyone has access. You can apply if you're here during the summer. I don't know if they're going to be in person or online yet. No one does. But that's the same topics, but obviously aimed at 18 plus. So they're going to be very much more detailed, very much more aimed at adults. Oh, sorry, that's essentially what I've just said. And yes, I'm going to return to my schools again this year to see if I can improve anything, whether they're still doing things. That's obviously a big one. See whether the parents are still involved as well. And that is about it. So thank you for listening, and please hit me with any questions now or type them, of course, and I'll stop sharing. So thank you.
Thank you very much, Greg. So really interesting. Is your website available to people to use it at the moment? Is it
currently not available to anyone. There's a login system, so it has to have that in order to keep track of people. So it has to have cookies and all sorts of things. So at the moment, ethically, I'm only allowed to give it to my students that I've been handed ethics for. But it is still being tested. So if anyone does want to just do some testing and give some feedback, that's fine. I can give you a test login, because all feedback is great. And I'd love to see if people find it boring or fun. It's all been very, very positive, but some mixed, some bad at the same time.
Yeah, I'm sure my kids would love to have a go on it.
Yes, absolutely.
Sign me up for a test one. That would be
Absolutely.
grand. Fabulous. Did anyone else? I mean, there was a comment in there just saying thank you. It's a very interesting project from Yasmin. Don't know whether there's anyone else had any questions in the meantime. Otherwise, we'll say thank you very much, Greg, and we'll pass over to Toby.
Great, thank you.
Thank you very much.
Okay, I'll just share my screen. Can you see my screen?
I can see your screen with
Yeah.
Teams front.
Yeah.
Yeah, presentation working form.
Okay, so my research is basically about sustainable development in port cities. So it focuses on different environmental, economic, and social aspects of that. This presentation is going to be about the social aspect. So just as some background, ports are obviously very important for the global economy. They're vital for the way of life that people enjoy, and they provide a range of benefits for port cities, such as increased economic growth, culture, identity, employment, and so on. However, they're also responsible for a range of negative impacts, such as pollution, traffic congestion, land use pressure. And a good example of this can be shown by Hong Kong, where the port contributes 54% of sulfur dioxide emissions. And a lot of these challenges are unique to port cities, and they're challenging to address because of the competing interests of ports and cities. Maybe the city might be more responsive to citizens, whereas the port might be a very commercially focused entity. And despite those challenges, port cities really should be central to any transition to a greener society, because they are a place where all of these major trends, such as urbanization, globalization, things like net zero initiatives, all come together. So the Sustainable Development Goals are very applicable to ports, such as sustainable cities and communities, life below water, climate action, responsible consumption and production. And ports are ideal locations to introduce things like renewable energy, maybe offshore wind farms, or circular economy because of all of the industry and consumers clustered together, or net zero. However, the social aspect of sustainable development is a little bit neglected at the moment. So that's what this presentation is going to introduce. So originally, port cities would have been, the link between the port and the city would have been very strong. The people who grew up in that city would have felt the presence of the port. Maybe they work in the port, their parents worked in the port, and so on. And that had a large impact on the heritage of the city, the sense of identity. And many modern cities completely have been changed entirely by the presence of the port. So a good example would be Liverpool, where many of the iconic buildings are related to the port. The local dishes, such as scouse, are from sailors who brought it in. The local accent is influenced by migration. The ethnic makeup, where 75% of Liverpudlians have Irish ancestry. The tourist attractions, such as the Albert Dock or the International Slavery Museum, and so on. So cities can use their maritime heritage to provide considerable benefits. However, ports are increasingly separated from cities, so it's not uncommon to see a port with a big metal fence, security checkpoints, and you can't really get in, you can't really see what's going on, especially with rising security concerns after 9/11. And whilst a lot of these negative aspects of ports, such as pollution, have continued to grow, a lot of the benefits they provide for the local area have reduced. So the OECD found that 90% of the economic benefits that a port provide now occur outside of the port. So using Southampton as an example, there's 11,700 jobs created by Southampton Port in the automotive sector in the West Midlands. So it's now much easier for a port located somewhere like Southampton to provide employment much further afield than it used to be, without really providing as many jobs in the local area. And there's also a lot of practices in ports, such as transshipment, where large vessels will come in, unload onto smaller vessels, and then travel onto smaller ports. So Rotterdam is a good example of where that happens, which provides very few benefits really for the local area. So really modern port cities can either become like non-port cities, potentially relocate the port away from the city to reduce the impact it has on the residents, or they can try to renew and improve the port city links. And I think sustainable development is an ideal way to do this. So things such as the circular economy, renewable energy, and so on. So in order to provide further social benefits and benefits from the maritime heritage, these are the key methods that have been used at the moment. The first one is port centres, which is essentially a visitor centre where you can go in, get some information about the port, see what jobs are on offer, how the port contributes to the city. There's also port information and social media, which is Facebook accounts, Instagram, Twitter, so on. Port education, where ports might make school trips and educate local children. Maritime museums, which is self-explanatory. Port events, such as the Southampton Boat Show. Public access, where people might take port tours. So I think Hamburg has a cycle path through the port area. And then the final one is local goodwill, which is basically the port putting money into charities in the area or scholarships for local students or things like that. So this current research basically aims to identify which of these measures are currently used, which measures are likely to be used in the future, and really what the ports think about the idea of providing social benefits. So I distributed a questionnaire to ports in 26 different countries. The idea was to make it a global study because a lot of the studies out there focus just on, quite often, one city or a country, or sometimes like the EU. So there aren't really any international studies on these issues. And for things like maritime museums, it's been noted in the literature that they're very much a European, North American, Australian thing, and they don't really occur that much outside, although recently it's started to change a bit. So the results found that ports basically agree that it's very important for the local population to be aware of the benefits the port can create. But they also feel that the local population do not have very positive attitudes towards the ports, and the ports feel under pressure to improve their local attitude towards them. So this should hopefully mean they're interested in initiatives that might benefit the local people rather than purely being financially motivated. So the current situation found that port information and social media is by far the most adopted option, followed by port events and education. These were all adopted by over half of the sample, with port information and social media being 81%. However, there wasn't any evidence in the data that adoption of these measures was related to improved attitudes among the local residents. And maritime museums and public access did show a positive association with increasing local awareness of the benefits of the port, but they're not as widely adopted. And port centres are at present the least adopted option. So in the future, the level of interest in port centres was much higher. And so really, I think they might be used as a hub for port city issues in the future. So you might see them cropping up in port cities. Education, public access and maritime museums also show increased levels of interest. And measures like social media didn't, partly because they're already so widely adopted. But I also think there isn't really any evidence they achieve anything in this area. So the final conclusion was basically that maritime museums and public access should be pursued as proven options for improving the local attitudes. And they're also something that the cities might be interested in as well. So I've also sent a questionnaire to cities, and maritime museums is something they're strongly interested in. And port centres might also be a useful tool. So I think that's the end. And now there should be an awkward silence.
Thank you very much, Toby. Hopefully not too awkward.
Yeah.
Let's make everyone aware that that last slide included some original artwork by Toby in relation where he was describing, was that a port of the future?
Yeah.
Prize-winning awards, prize-winning artwork. William has his hand up with a question.
Yeah. So I just didn't want there to be an awkward silence. So, but I know it's really, actually, I just like to say that I think all of the talks have been really brilliant. They've been really sort of concise. they've been very understandable. I mean, no, we haven't finished yet, but they've been very understandable to sort of somebody who doesn't necessarily have the technical background. And I think it illustrates the sort of breadth of stuff that's going on, all within those sort of UKCRIC objectives. But I just wanted to say, really following on from Toby's, that there was a call recently for networks that was meant to sort of plug into the UKCRIC network, UKCRIC group. We've put in a proposal which was actually on port and coastal towns and cities, and it actually involves, well, Southampton, Lancaster, University of East Anglia, because you've got the sort of Norfolk seaside towns, Strathclyde, Brighton are in there, and Belfast. And I don't know yet whether we will get it. I mean, it's one of those horrible things where basically we've got a 1 in 2 chance of success, but actually they're probably 6 really, really good bids, and they're going to sort of fund 1 in 2 from a number of things. We'll hear fairly shortly. But even if we don't get it, I do think that actually this is a bit of a thing that we should be looking at developing. And I think some of the insights that you've given us there have been really great. So hopefully we'll have the opportunity to sort of build on some of that in the future. So thanks very much. And thanks to all of you as well for the presentations. They've all been really good.
Thank you, William. So I don't think there's any specific questions for you, Toby. So thank you very much for your time.
No problem.
Our last presentation is from Lewis. Are you there, Lewis?
I am. Hello.
Fabulous. Thank you for being so patient and waiting to the end.
Okay.
We've still got plenty of time, so we look forward to hearing from you now.
Okay, can everyone see that, sorry?
Yes, we can. Hear you clearly as well. Thank you.
So hi, my name is Lewis Tolman. I'm currently in the 4th year of my PhD in the CDT SAS, where my project is looking at the ecological effects of river restoration in English chalk rivers. So today I'm just going to give you a really quick talk about my first project, which is titled Supporting the Dam Removal Movement, Providing the Evidence for Small-Scale Structures. Hope you enjoy. So just a bit of a background to chalk rivers. These are any rivers which derive over 75% of their base flow from these underground chalk aquifers, which are really important in southern and eastern England. And these systems are really rare globally, so about 85% of them are found in England, again, particularly in the south and east of England. And because they have this unique geology, they also have very unique conditions, particularly they're very stable, so they have very stable flow, temperature, and chemistry, which allows really diverse ecological communities to thrive in these habitats. But like most European rivers, chalk rivers are really threatened, so only about 13.3% of them are currently classed as in good ecological condition, and about 0% are in good chemical condition. So really, these are very impacted systems. There's many reasons for this, but just a few. So abstraction for our water sources, pollution from things like fine sediment pollution, which is from agricultural runoff, and modifications of the channels with things such as infrastructure such as weirs, which is what this study concentrates on. So for those who don't know what weirs are, they're essentially similar to dams, and their purpose is to block off the river, generally to divert flow for things such as agriculture. And there's quite a lot of them in the UK. So in this recent paper, there was over 16,000 individual structures under 5 meters in height in the UK, and these are just the ones that have been recorded. And because these rivers block the flow of the water, they can severely impact the habitat and ecology of a river. So in this diagram here, where on the left is the upstream of the weir and the right downstream. You can see the upstream sections, the weir typically creates a very pond-like system, decreases the flow, increases the depth and fine sediment deposition, and generally changes the ecological communities to more pond-like one. Downstreams, the weir can restrict the flow, prevent the upstream movement of migratory fish, and generally just coarsens the substrate. And because of this, there's been a real increase in interest in removing weirs for restoration of the river habitat to generally improve habitat, dynamics, and ecology. And in many cases, this has been proven to work really well, and you do see these benefits from weir removal. However, there's actually really few studies that assess the ecological effects of weir removal, and even less so in this really low-powered sort of unique systems such as chalk rivers. So this study sort of aimed to fill this gap and provide some evidence for the effects of weir removal in chalk rivers. So the aim of this study was to quantify the environmental and ecological effects of weirs and their removal in chalk rivers. To do this, we had two objectives, but today I'm only going to talk to you about the second one, which is to use a case study weir removal restoration to determine the effects of restoration on upstream and downstream habitat and invertebrate communities. So the weir that we looked at was on the River Test, which is local to Southampton, and in August 2017, the Environment Agency moved a 1.5 metre high weir, primarily to with the aim of improving upstream passage of salmon, as well as to improve habitat and general biodiversity. So what we did was we monitored the effects of this by looking at 10 transects located 20-metre intervals directly upstream of the weir and downstream of the weir prior to restoration, so in 2016 and 2017, and post-restoration yearly, so 2018, 19, 20 and 21. In particular, we monitored habitat, so things like depth, velocity, types of substrate, and we did this through physical methods, so just going into the river and taking these data points, as well as using a thing called an arc boat, which is essentially it's a massive remote control boat with sonar on the bottom, so it can tell us the bathymetry of the river. We also assessed the macroinvertebrate communities using simple kick sampling netting methods to take a sample of that population. We then did some statistical modelling to assess the responses of these metrics to the restoration, comparing before and after. So the first of these results, so just a heads up, these are just a look portion of the results. There's quite a few more. So if you want to see those, please do let me know and I can send some graphs. So these are interpolation maps generated from ArcBoat data. So on the left 4 maps, we have the depths, and on the right 4 maps, we have the velocities and the respective scale to the rights of each map. The first map on the left for each of these is the pre-restoration sample in 2016. And as you can see, the maps of the, as you can see in these maps, the site directly upstream of the weir is really deep, very slow velocities of about 0.1 centimeters per second, which for these kinds of rivers is really slow. And it clearly shows that this weir has created a pond-like system in upstream reach. Downstream, the impacts are a little less obvious, but it also seems to be showing there's some sort of flow restriction and reduced velocity because, probably because of this weir. When the weir was removed in 2017, there was a quite drastic change, especially in the upstream site. So the depth was really reduced and the velocity was increased considerably, as you can see in the graphs here. You can also see in the upstream site, it started to develop a sort of a channel in the middle of the river, which is generally creates more variable habitat, and it's really good for ecological communities as it provides a number of different habitats and likely supports a more diverse ecological community. Just quickly, this graph shows the substrate composition at each sampling date, and prior to restoration, the upstream site is very dominated by fine sediments, such as silt, and this really makes sense given the sort of reduction in velocity caused by this weir, which decreases the transportability of the river for these fine sediments, so they just get deposited in this section. Comparatively, downstream showed a lot more variable substrate composition, which is what we expect given the effects of that weir. The removal of the weir caused a large shift in the substrate composition, so upstream became a lot more dominated by core substrates, which is more what we would expect in an unimpacted modern short river. Interestingly, we didn't see a large increase in fine sediments downstream of the site either. So what we expected is, because we had all this fine sediment upstream of the weir, when we removed it, it would simply wash down into the downstream stretch and persist there and cause impacts, just because these rivers have really low power, so they don't have quite the ability to erode that way. But we didn't see this, and it suggests that there's actually not going to be big long-term impacts of this restoration as we do see in other sites, which is really positive. Supporting this, here we have some invertebrate results. So the graphs here show the abundance, the number of families, so this is a sort of a measure of diversity, and how tolerant the community, so this is a metric that we calculated, so it's how tolerant the community is to silt, where lower values mean the community is comprised of a lot more silt-tolerant species. So generally it just shows you that there's a bigger impact of silt in these systems. And a similar thing with flow. So again, here it shows the lower the flow value, it shows you there's a lot more species which are really poor at dealing with high flow. Again, suggests that there's an impact of this weir. And here again, the grey area shows pre-restoration samples, the black dashed line shows upstream samples, and the solid grey line shows downstream samples. And as you can see, generally the restoration has a really positive effect on the community, and we see there was an increase in abundance, especially in the upstream site, and an increase in the diversity of invertebrates in both sites. Likewise, prior to restoration, the silt and flow tolerant metrics show upstream was comprised of a lot more silt tolerant, flow intolerant taxa, which is to be expected given the habitat conditions we saw. But the removal of the weir changed the upstream site considerably and allowed silt-tolerant, flow-intolerant taxa to colonise that reach, as we would expect in an unimpacted modern chalk river. So altogether, these are really positive results in terms of the invertebrate community, and it generally shows that there was a good effect of this weir. So to conclude, the removal of the weir reinstated a more natural habitat, which created an ecological community closer to that of what we expected in these rivers. And generally it shows that weir removal can be a useful technique to restore these rivers despite their low flow. Again, so this was, I cut out a lot of the results of this objective just with considering time. So if you have any more questions or you want to see any more graphs, please do let me know. Aside from that, I am finished.
Thank you very much, Lewis.
Okay.
Yeah, interesting to see the effects of just kind of removing a few bits and pieces from the river, just how much effect it does have. And are there long-term effects? Is there kind of data about kind of the long-term effects of kind of changing the rivers in this way?
Well, there's a lot. There is long-term studies, but generally they're about. This is quite a long study for over 5 years in the grand scheme of things. There are longer ones, but in chalk rivers they're generally about 2 or 3 years after restoration. Which, looking at the long-term effects, isn't that long, really.
No, it's good to see that kind of the work's being done and it's being investigated. I think, I suppose these streams perhaps do not get as much activity as kind of some of the larger rivers with the huge hydro power dams and things. But do you think that kind of this sort of research could be scaled up to kind of consider kind of blockages in larger rivers as well?
Well, so this is actually part of the issue, is because a lot of the work has been done in the US, where generally they are looking at these larger dams. There's a really big bias to looking at these larger dams. So if anything, we need to look at more smaller dams because they're much more prominent. They're distributed across the river and they, in a way, impact across the river basin. So yeah, that was actually one of the biases, the opposite bias of that.
Yeah. And that's good to see that they are kind of taking both sides of the problem and kind of looking at it. Perfect. Well, thank you very much, Lewis. If anyone else had any questions, now is the time. I think in the chat there was a question for Toby. I don't know whether he'd been able to see that yet.
No, I hadn't. I'll have a check.
That's okay. So
I can't actually read the bottom of it for some reason. Oh, okay. How did I construct the international surveys? So basically, I just used a literature review to decide what questions I'd ask, and then I approached experts mostly through LinkedIn, actually, and distributed the questionnaire through there.
Brilliant. Do you find social media and things like LinkedIn as particularly helpful for your research?
I think so. I mean, before that, I was trying to use email addresses and calling people up, and I couldn't really get that many people to agree to take part. Once I started to use LinkedIn, I got a lot more very quickly. So I think it's not really been used that much in research before, but I think if you need to speak to people for questionnaires, I think it's definitely worth trying.
Do other people in the network use things like social media, Twitter, LinkedIn, that sort of thing for kind of gathering data or disseminating data? Do you find it kind of any useful places?
So I know he's not actually in this meeting, but I know Jack Daniels, he's not. So he's looking at the sort of distribution of invasive species across the UK and globally. He's using images, so geotagged images, to sort of assess the distributions of invasive species, primarily from people using, they go and they catch a fish, and generally the first thing they do is they post it on Facebook or something. So he's using the geotagged images of that to sort of map their distributions. Again, he's not here, so I'm sort of talking about his project for him, but maybe in the future.
Yeah, absolutely. So I was wondering whether it's worth setting up a LinkedIn group for this particular network, whether people would find that a useful thing to do, or whether it's just another layer of social media to manage. Yeah, feel free to let me know if that's something that you are kind of interested in using or kind of being part of. So I will share my last slide. There we go. So our next webinar is the same this time next month. And this time we'll be hearing from another Centre of Doctoral Training, this time based at the University of Sheffield. And it's called the Energy Storage and its Applications. This is a similar age CDT to the CDT SIS, started at the same time on the 2013 funding. So they're coming to the end of their last cohort. So we'll be hearing from them about storing energy and all the challenges that relate to batteries and net to grid and kind of net zero problems and things like that they will be having. So you can register for the webinar through the UKCRIC.com events page. It will take you through to the Eventbrite to register for that particular webinar. It'd be really great to see you all there again. I think the time is slightly different. It's 1 till 2 o'clock. We may extend it to 2:30 if there's a lot of people presenting. Otherwise, like I say, we use Twitter, so hashtag UKCRIC Doctoral Skills Network. If you want to continue the conversation online, I will be putting up some photos from this particular event and also uploading the recording of this webinar to the UKCRIC website in the next few days. Also on the UKCRIC website, there's lots of other webinars and seminars and events that you are free and available to get involved in. Over the next few months, we will be hosting a number of skills and training workshops and events either hosted by particular universities or by UKCRIC teams as it is at the moment. So I really look forward to seeing a good number of you there and getting involved. To say, drop me an email at any time, or feel free to kind of put things through on the Twitter or we will potentially look up the LinkedIn pages. But no, it's been really great to spend time with you today. And if anybody else has any other questions, otherwise I'll say good afternoon.
Thanks, everyone.